Hello, welcome to the video. In this lesson, we're looking at section 9.5. We're going to be looking at the sine and cosine ratios. So in the previous lesson, we looked at tangent ratios, and tangent ratio with respect to whatever angle they gave us that wasn't the 90-degree angle. You were able to use the ratio of opposite side length of that angle divided by the adjacent side length of that angle. Today, we're going to be looking at both sine and cosine. The reason why sine and cosine kind of go together is because you are going to be using the hypotenuse of the right triangle to help you discover what those ratios are. So in this particular chart or this particular table, they're both using it with respect to angle A. So the sine of angle A is, if you look at it, it's a ratio where it's the opposite side length to that angle measurement divided by the hypotenuse, right? The hypotenuse never changes. Doesn't matter if you're looking at angles A or angles B. If we're looking at cosine now, cosine, the numerator is the adjacent side measurement divided by the hypotenuse. So kind of the same idea as tangent, just you are using different side values to get your ratio. All right, so here they're asking us four things. They want us to find these two sine ratios and then these two cosine ratios. All right, just like what we did in previous section, they want the fraction and they want the decimal rounded up to 4 decimal places. So let's look at sine. So I got sine of s. We'll look at that first. So sine of s is right here. Sine is opposite, so the opposite of that is 63 divided by the hypotenuse, which is 65. So 63 divided by 65, can that then be reduced? No, it can't. So that is my lowest term fraction, and my decimal rounded up to 4 is going to be 0.9692. All right, so now looking at the sine of r with respect to with that, it is going to be opposite, which is 16 divided by the hypotenuse, which is 65. So 16 divided by 65, is that in lowest terms? Yes, it is. So the sine of r is that ratio in lowest terms, and in the decimal form, rounded to 4 decimal places, it's going to be 0.2462. All right, so there's my 2 decimals. All right, so now let's look at cosine. So now cosine of s, again right here, is going to be equal to the adjacent value, which is 16, divided by the hypotenuse, which is 65, which we actually already did. So if you notice, it's that value right there. And that is going to be equal to 0.2462. All right. Cosine of r, I bet you is going to be the opposite of just like sine s. So if we looked at r, adjacent is 63, hypotenuse is 65, it's the same as sine s, and it's going to be a ratio of 0.9692. So if you did notice that the sine of s and the cosine of r were the same. Same thing goes for cosine of S and sine of R. We're also the same ratio. Well, there is a concept with that, and what it is, it's being able to discover the sine and cosine of complementary angles. So you can rewrite the sine of something with respect to cosine. So the sine of A is actually going to be equal to the cosine of B. And then the cosine of A is the same as the sine of B, that just gets flipped. And then the sine of B is going to be the same as cosine of A, and cosine of B is going to be the same value as the cosine of A. All right, so it's the same thing we just had here. In this case, the sine of S is going to be the equal to the cosine of R. Sine of R is going to be the same as cosine of S, so it's the same thing. So basically what they're saying is you can figure out what it is by just taking the 90 and subtracting by whatever these angle measurements are, and then finding what is going to be equal to the respected other trig function. So for instance, they're asking us to write sine of 56 in terms of cosine. So we want it to be equal. So to make it equal, what you're going to do is you're going to take 56, you're going to take 90 and subtract it by 56, and that is going to be equal to 34. So that means that the sine of 56 is actually going to be equal to the cosine of 34. All right, so if you wanted to see if that works out, so if you were to type it in your calculator, so if I put in sine of 56, I'd get 0.8290. So let's see if it works for cosine of 34. I should get the same value, in which I do. So that's a way to check it. All right, so now here, same idea with tangent. Now we're going to be asked to use sine and cosine. In this case, we're actually trying to find two unknowns. We're trying to find x, and we're trying to find the values for y. They give us 26 degrees at this spot in the right triangle here. So if we try to find x first, that is opposite of the 26 degrees, and we know the hypotenuse. So that means we are going to use the sine of 26 degrees, which is going to be equal to x over 14. So to find x, multiply 14 to both sides. X is going to be equal to the sine of 26 multiplied by 14, and that is about, and so they want it around the nearest tenth, 6.1. All right. To find y with respect to this 26-degree angle that's adjacent, so that's going to be the cosine of 26 degrees is equal to y over 14. So again, multiply 14 to both sides. I got the cosine of 26 degrees, times it by 14. Y is going to be about 12.6, so round to the nearest tenth. All right, so here it says find the sine and cosine of a 45-degree angle, and then it says find the sine cosine of 30-degree angle and sine of cosine with 60 degrees. So this was kind of similar to what we did with those special right triangles. So let's say we have our right triangle and this is a 45, 45, 90. And then let's look at the 30, 60, 90. So again, um, since these had to be the same, we're going to call this 1. All right, so if we left it as 1, this is going to be the square root of 2. And if this was 1, this was 2, and this is going to be square root of 3. So we're going to use that theorem to help us determine what those special products should be, and let's see if it validates those theorems. So looking at sine and cosine of 45 degrees, so let's say sine is going to be equal to, so sine of, 45 is going to be equal to opposite, which is 1 divided by the square root of 2. So since you can't have a radical in the denominator, you're going to multiply both the top and the bottom by that. So then this is going to be equal to um, the square root of 2 all divided by 2. And if you were to attach this as a decimal, square root of 2 divided by 2 is about 0.707, we'll say. Let's see if that works out. So if I go over here and typed in the sine of 45 degrees, yep, I get that about same value. So that validates that part of the theorem. So now if I go to the cosine of 45 degrees, that's going to be equal to, and now this is adjacent, so that's 1 over square root of 2 again. So this is again going to be equal to the square root of 2 over 2. All right. So that checks out. So now if we look at the 30 degrees, so sine and cosine of 30, so sine first, sine is going to be 1 over 2, and cosine of 30 degrees is going to be the square root of 3 over 2. All right, so again, let's look at this. So sine of 30 should be 0.5 if we get it in a decimal form, which we do. And square root of, let's see what square root of 3 divided by 2 is. So it's at 0.866. So if I went cosine of 30, I get the same thing. So put 30 in there as well. All right, so now to finish up, sine and cosine is 60. So I got the sine of 60 degrees. That is going to be equal to square root of 3 over 2, which is, remember, kind of ties in with that one. So I'm led to believe that cosine of 60 is going to be 1/2. All right, just to double check it, cosine, or let's go sine of 60, it should be that 0.866, which it is. Cosine of 60 should be 0.5, which it is. All right, so here it is asking us, oh, sorry, you are skiing on a mountain with an altitude of 1,200 feet. The angle of depression is 21 degrees. It's asking you to find the distance x you ski down the hill to the nearest foot. All right, so x is part of the hypotenuse, this 21-degree angle with respect to the altitude of 1,200 feet is the opposite side measurement. So we are going to be looking at the sine of 21 degrees, which is going to be equal to 1,200 divided by x. So if I multiply x to both sides, that gets canceled. And I divide everything by the sine of 21. So now I get x is equal to 1,200 divided by the sine of 21. So 1,200 divided by the sine of 21 gives us a value of 3,348.51. So it's asked us to the nearest foot, so that means that it's going to be 3,349 feet. And that is being able to use the sine and cosine ratios. Hope this helps. Till next time.